On a mid-August day in 1943, over 200 B-17 Flying Fortresses approached their target at high altitude over Bavaria. Through bombardier sights, crews watched anti-aircraft fire erupt around them as factories responsible for producing the majority of Germany's ball bearings came into view through the haze. German aviation depended on millions of these components monthly, and Allied planners believed destroying this production could cripple the enemy's war effort. As bombs dropped and fighter aircraft attacked the formations, a starkly different situation existed back in the United States. Despite the mission costing 60 B-17s and over 100 crew lives, American manufacturing was producing an alternative that didn't rely on German technology and performed better in most situations: tapered roller bearings. This account explores how a German immigrant carriage maker developed a revolutionary bearing design in the late 19th century, how his enterprise became America's response to Germany's dominance in ball bearing manufacturing, and how this mechanical innovation contributed significantly to Allied victory in the Second World War. Converting kinetic energy into heat while damaging surfaces represents a fundamental challenge in all mechanical systems. Henry Timken, who emigrated from the Kingdom of Hanover, believed that whoever could meaningfully reduce friction would create something genuinely valuable. Born in 1831, Timken arrived in America as a young child and his family settled in Missouri. After apprenticing with a prominent carriage and wagon manufacturer during his youth, he established his own carriage manufacturing operation in St. Louis by his mid-20s. His patent for an innovative buggy spring in 1877 brought him national recognition and commercial success, with many companies producing it under license. Around the mid-1890s, Timken became interested in friction-related challenges in wagon construction. While conventional 19th century bearings handled vertical loads reasonably well, they struggled when wheels needed to bear significant lateral forces, such as during turns. Ball bearings, the predominant friction-reducing technology of that period, used spherical elements rolling between inner and outer rings. Though excellent for light loads and rapid rotation, they had significant limitations when subjected simultaneously to heavy perpendicular and parallel forces, exactly what wagon wheels experienced. Working with his two sons and a nephew, Timken experimented with creating an improved design. Their breakthrough concept replaced spheres with cone-shaped rollers arranged at angles between similarly cone-shaped rings. This configuration enabled the bearing to manage both types of loads simultaneously. Timken secured patents for his tapered roller bearing design on the first day of May, 1898. The innovation was remarkable. His bearings could support 5 times the weight of comparable ball bearings, while maintaining reduced friction and extended service life. He incorporated the Timken Roller Bearing Axle Company the following year, initially operating from a section of his St. Louis carriage facility. As Timken developed roller bearings in America, German manufacturers dominated global ball bearing production. In 1883, Friedrich Fischer and his son pioneered mass production of precision steel balls in Schweinfurt using grinding machinery. Their operation eventually merged with another shop to form a major German bearing company in 1909. Another enterprise, the Swedish-based SKF, founded in 1907, rapidly expanded internationally. Within a year, SKF had established branch offices across Europe, followed by subsidiaries in America and numerous other countries. It became the planet's largest bearing manufacturer. Before the First World War, most ball bearings used in American industry were imported from Germany. German firms had established commanding positions through superior metallurgical knowledge, precision manufacturing capabilities, and aggressive international expansion. Timken's travels to Germany in the early 1890s provided him with competitive intelligence. He observed cutting-edge internal combustion engine technology and witnessed advanced bearing development that placed Europe years ahead of America in bearing production. However, Timken's tapered roller design offered advantages that German ball bearings couldn't replicate. For heavy-duty applications including trucks, railroad equipment, and industrial machinery, tapered rollers vastly exceeded ball bearing performance. The geometric design distributed weight across a line rather than a point, dramatically increasing capacity. The company relocated to Canton, Ohio in 1901 to be closer to Detroit and Cleveland's emerging automotive industry, and the steelmaking centers of Pittsburgh and Cleveland. By 1920, Timken was producing 90% of America's tapered roller bearings, with manufacturing facilities expanding across North America. Railroad adoption proved crucial. Following successful tests on streetcars and freight equipment in the early 1920s, major American railroads began specifying Timken bearings for their high-speed passenger trains. When the First World War erupted in 1914, Germany's ball bearing monopoly became a strategic asset. The British blockade severed German exports, creating shortages in American industry that had depended on German bearings. However, American manufacturers found themselves unable to quickly substitute because precision ball production required specialized equipment and expertise concentrated in Germany. Timken, however, already possessed production capacity for tapered rollers, a different technology that performed better for many uses. The war demonstrated that tapered roller bearings could replace ball bearings in most military vehicles, equipping trucks, artillery carriages, and heavy equipment. This performance impressed European markets. Henry Timken passed away in 1909 before witnessing his invention's full impact. His sons continued building the enterprise. In 1917, facing wartime steel shortages, the company began steel and tube manufacturing in Canton to vertically integrate and control bearing steel quality. This decision proved critical. Producing steel internally meant controlling composition, heat treatment, and quality throughout the process, while protecting against supply disruptions. The company weathered the Great Depression in strong financial condition, expanding into non-automotive markets including agriculture, machine tooling, industrial equipment, and rail. During the early 1930s, Timken developed bearings for propeller drive shafts and began manufacturing removable rock bits for construction and mining equipment. By 1943, Allied intelligence had identified ball bearings as a critical German weakness. The German armaments minister warned his leadership that tank production and ball bearing facilities were crucial to the entire war effort. Schweinfurt in central Bavaria hosted 4 ball bearing manufacturing complexes that collectively produced roughly half of Germany's total output, employing thousands of workers. The U.S. 8th Air Force planned to cripple German war production by destroying these factories. On August 17, 1943, hundreds of B-17s took off to attack Schweinfurt and other targets. The mission proved catastrophic. Over 3 dozen B-17s attacking Schweinfurt were lost, representing nearly 16% of that force. Combined with other losses that day, 60 B-17s were destroyed. Despite devastating effects on bombing targets, German ball bearing production plummeted temporarily from 140 tons in July to 50 tons in September, a 64% reduction. A second raid in October, known as Black Thursday, saw 60 of 229 attacking B-17s lost, a 26% loss rate. Such casualties were unsustainable, and deep penetration missions without long-range fighter escorts resulted in catastrophic losses. Despite these devastating raids, German ball bearing shortages never crippled war production. 3 factors prevented collapse. Germany had accumulated enormous reserves with factories maintaining months of inventory as buffers. They imported ball bearings from neutral Sweden and Switzerland. And where possible, German engineers redesigned equipment to use simpler bearing types that required more frequent maintenance, but could be manufactured with less critical materials. Post-war analysis confirmed skepticism about the campaign. Despite costing hundreds of American lives and dozens of bombers, it achieved limited strategic effect. By 1945, Germany had assembled more bearing reserves than ever, with production dispersed to underground facilities and smaller shops. While B-17s burned over Schweinfurt, American factories were solving the bearing challenge differently, not by bombing German facilities, but by producing alternatives that worked better. When World War II began, Timken's production increased dramatically, with several new Ohio facilities opening. The statistics are remarkable. Every U.S. Jeep used 24 Timken bearings, and with 660,000 Jeeps delivered to the military, Timken produced over 15.8 million bearings for Jeeps alone. Trucks required dozens more bearings each. Tanks used Timken bearings in multiple systems, and artillery pieces, aircraft landing gear, and ship propeller shafts all used tapered roller bearings. The advantage wasn't merely that Timken bearings worked, they often worked better than ball bearings for military applications. Tapered rollers handled combined perpendicular and parallel loads far better, which tank tracks and truck wheels experienced constantly. Line contact between roller and ring versus point contact in ball bearings distributed loads, reducing stress and extending life. Tapered roller bearings could also be adjusted to compensate for wear, while ball bearings once worn required replacement. By war's end, Timken had produced hundreds of millions of bearings for Allied military equipment. The company's vertically integrated model, producing steel and machining bearings while controlling quality throughout, proved superior to relying on global supply chains that wars disrupted. The physics favoring tapered roller bearings were fundamental. A ball bearing contacts its ring at a point, which under load deforms into a small ellipse, but contact area remains tiny with stress concentrated intensely. A tapered roller contacts its ring along a line, which under load deforms into a narrow rectangle with much larger contact area. Stress distributes over greater area, reducing peak stress. In ball bearings, only a few balls carry most of the load under combined loads. In tapered roller bearings, all rollers share loads more evenly due to geometry and precise positioning. Tapered roller bearings can be preloaded and adjusted to eliminate clearance and optimize contact, while ball bearings have fixed clearances determined during manufacturing. The larger contact area in roller bearings also conducts heat away more effectively, reducing operating temperatures. For military vehicles operating under harsh conditions, shock loads, heavy weights, poor maintenance, contaminated environments, these advantages were decisive. Timken bearings survived conditions that destroyed ball bearings. German engineers knew tapered rollers existed, but their manufacturing was concentrated in ball bearings. Converting production would require retooling factories, retraining workers, and redesigning equipment. Impossible during wartime. Following World War II, much machinery shipped to Europe under the Marshall Plan was equipped with Timken bearings, helping the company establish broader presence in markets where European competitors had dominated. Despite legal challenges regarding territorial agreements with foreign affiliates, Timken continued expanding globally throughout the latter half of the 20th century. By 1960, Timken operated across multiple continents. In 1974, they opened sales operations in Japan, bringing American tapered roller bearings to compete in one of the world's most demanding bearing markets. Throughout subsequent decades, Timken expanded into numerous additional countries. In 2003, Timken acquired a major competitor for $840 million, doubling company size and creating the world's third-largest bearing manufacturer. In 2014, the company separated bearing and steel operations. As of 2024, the Timken company reports $4.6 billion in sales and employs more than 19,000 people globally, operating from 45 countries. Timken remains the world's largest manufacturer of tapered roller bearings, a position held continuously since the 1920s. The product line has expanded to include various bearing types, gear drives, automated lubrication systems, and power transmission services, but tapered roller bearings remain central. The ultimate irony is that Henry Timken was German. Born in Hanover, he immigrated as a young child and became thoroughly American. But his engineering sensibility reflected German thoroughness and precision. His trips to Germany in the 1890s exposed him to European bearing advances. German ball bearing manufacturers pioneered precision manufacturing, and Swedish SKF created global distribution networks. But these companies focused on ball bearings because that's what they knew. Timken saw what established manufacturers didn't: that for heavy load applications, rollers beat balls. The tapered geometry he patented in 1898 solved problems that ball bearings couldn't. When World War II came, American industry had a domestic bearing manufacturer that didn't depend on German imports, didn't require Swedish neutrality, and produced bearings superior for most military applications. The Schweinfurt raids, though devastating to German production, weren't necessary to keep American war production running. Timken factories in Ohio were already producing everything needed. German leadership spent the war worried about ball bearing supplies. Their American counterpart didn't have that concern. Timken had it covered. Modern bearing technology vindicated Henry Timken's innovation. Today's heavy equipment overwhelmingly uses tapered roller bearings and automotive wheel bearings for trucks and heavy-duty vehicles, aerospace landing gear and gearbox applications, rail freight car axles and locomotive drives, and industrial applications including wind turbines, mining equipment, and steel mills. Ball bearings remain optimal for high-speed, light-load applications like electric motors and precision instruments. But for combined-load, heavy-duty applications, tapered rollers dominate. The physics Henry Timken exploited in 1898 remain unchanged. Line contact distributes loads better than point contact. Tapered geometry handles combined loads better than spherical geometry. And adjustable bearings adapt to conditions better than fixed bearings. These principles, worked out in a saint, Louis Carrière's shop, became the foundation for a global industry. While historians debate whether bombing Schweinfurt mattered, there's no debate about whether Timken bearings mattered. They were in every Jeep, truck, tank track, and ship propeller shaft. The tapered roller bearing won no headlines and appeared in no dramatic photographs. Generals didn't discuss bearing strategy at major conferences, but logistics officers knew that without bearings, vehicles don't move, and without movement, armies can't fight. Germany entered World War II, dependent on centralized ball bearing production. Vulnerable to bombing, America entered with dispersed, tapered roller bearing production, immune to attack. Germany spent the war scrambling for Swedish imports and substituting inferior alternatives. America spent the war producing superior bearings in unlimited quantities. The advantage wasn't dramatic. No single battle turned on bearing supply, but aggregated over millions of vehicles, billions of operating hours, and 6 years of war. The cumulative advantage was enormous. Every bearing that didn't fail meant one less vehicle disabled. Every vehicle operational meant supplies reached the front, which meant offensives continued, which meant victory. Henry Timken passed away in 1909, never knowing his invention would help win the greatest war in history. He just wanted to build a better bearing for wagons. He succeeded beyond imagining. The immigrant from Tarmstedt, who apprenticed as a carriage maker at 16, invented something of real value to the world, exactly as he'd intended. The tapered roller bearing reduced friction fundamentally. It still does. And while American bombers died over Schweinfurt trying to destroy German ball bearing factories, American factories quietly produced something better. Not through dramatic raids or strategic bombing, but through patient engineering and mass production. The bearing war was won not in the skies over Bavaria, but in factories in Canton, Ohio, where a German-born inventor's creation, perfected by his American company, rolled off production lines by the millions. America didn't need German ball bearings in 1940. It had something better.